Hi guys, now today we are going to learn about Black-Scholes-Merton model. This model is important because the other model that we were talking about, we know the binomial tree model, which is a pretty simple method, but it cannot be used for complex calculations of option pricing, option value. So since it can only calculate about up to 2 years, we can calculate up to 3 or 4 years because it becomes, if we do that, it becomes very tedious. So considering that Black-Scholes and Merton has developed a model using some formulas, we will be able to find out the value of options. So we'll be seeing how to develop, what are the formulas and how we'll solve those problems using Black-Scholes-Merton model. Coming to the most important Black-Scholes-Merton model. So if you see, to derive the Black-Scholes-Merton model, riskless portfolio is considered. The same portfolio is being considered for our finding out binomial tree model also. Many places this riskless portfolio model will be considered. Why? Because a riskless portfolio is sure to give risk-free rate of return. So the rate of return will automatically get from there. So finding out something with that becomes very easy. So there are certain assumptions that has been taken by our BSM model, which I'll list here. Price of underlying asset follows log and normal distribution that I've already told you. The continuous risk-free rate is constant, known and always available for borrowing and lending, which is an assumption which has been taken, which is not very true. As you know, borrowing and lending rate at risk-free can only be done by major banks, etc. It cannot be done by everyone. So trading is continuous. Trading may or may not be continuous, but trading is assumed to be continuous by BSM. Volatility if underlying asset is constant and not, which is not true, but assumed by BSM model. Option values depends on volatility of price of the underlying asset or interest rate. That is true. That is true. Yeah, right. Markets are frictionless. There are no taxes, transaction cost, restrictions, short sales, and use of short sale proceeds, which is a very big assumption taken by BSM. And the underlying asset has no cash flow, such as dividend and coupon payment. This is also an assumption, weird assumption. The option valued are European options, which can only be exercised at maturity. The model does not correctly price American option. So you can value European option having all these assumptions. Still, the Black-Scholes-Merton model is the only model that values options properly. So we are using it even now. So binomial tree model can value up to a definite time period, maybe 1 or 2 time periods. After that, we will have to use Black-Scholes model. Even if there are many weird assumptions taken by BSM model. So coming to the real Black-Scholes-Merton formulas. So there are two formulas which is given by Black-Scholes and Merton. The derivation of it, which is very difficult, so and very lengthy. So anybody doing this valuation should be doing with this formula by hearted. We cannot write down the derivation in one page, so we'll go by this formula as of now. First, you'll have to by heart this formula of call finding out the call value. This is a formula for finding out put value. So with this, you'll be able to, if you remember this formula, you will be able to find out the value of call and put. But for finding out the value of call, after finding out the value of call, you don't have to use the put formula. You directly use put call parity. I'll explain to you what it is. So by using Black-Scholes formula, call value is equal to S0 into ND1 minus X, that is a strike price, into e raised to minus RT. R is continuously compounded risk-free rate into 2, T is time to maturity, and ND2, which is cumulative normal probability of that event happening, then ND1, cumulative normal probability for this happening. So D1 and D2 is nothing but ln into S0, that is stock price, divided by strike price, plus risk-free rate, plus 0.5 into sigma square, into, that is sigma square by 2 into t time period, divided by sigma into root t. So D2 is equal to D1 minus sigma into root t. So this is how we find out this, and with that ND1 will be finding out using our table. So this is a outline of these formulas and Black-Scholes-Merton formulas. With the while finding out the C0, we'll be finding out P0 with using our put call priority theory, which is nothing but value of call is equal to value of call plus our strike price into e raised to minus continuously compounded rate into t is equal to P0 into stock price at 0. So using that formula, we'll be rearranging it and finding out put value also if you get the call value. But while explaining this, you may not understand this. You'll have to go to the problem. So we'll take up a problem. Coming to the problem, suppose the value of Vola Incorporated is trading at 50, strike price X-rays price 45, in 3 months continuously compounded risk-free rate is 5%, standard deviation is 12%. BSM model, calculate the value of call option. So for calculating the value of call option, first we'll have to calculate D1 and D2. From D1 and D2, it's a simple calculation to value our call and a put option. So we'll be finding out call option since only call option has been asked. If put option is being asked, use the simple formula of put call parity. So it is like D1 is equal to ln into stock price divided by strike price, which is 50 by 45 plus 0.05, which is the risk-free rate, plus 0.5, which is the formula, into 0.12, that is our annualized standard deviation square, into 0.25, that is the time period of 3 months, divided by 0.12 is again the standard deviation into root of 0.25, that is 1/4 of an year. So which gives us 1.99. So from D2 is only 1.99 minus the denominator of this. Always keep in mind while calculating this, you don't have to calculate the denominator again. The denominator, this value again, we'll have to just use this value here also and subtract it to get 1.93. So from partial cumulative normal distribution table, we'll be getting 1.93. There is a table known as that you might be very familiar with. If you are not, also no worries. Most of the question asked, they'll be giving it. Nobody will ask you to go to normal table and find it out. So this will be given. So 1.93 is correspond to 0.9732 and 1.99 corresponds to 0.9767. So ND2 is equal to 0.9732 and D1 is equal to 0.9767. So finding out this is ND1 and this is ND2. So finding out call option is equal to our stock price is into ND1 minus strike price into e raised to 0.05 into 0.0525 into ND2. So putting that formula, we'll get 48.84 minus 43.25, which is 5.59. This is simple. Putting a formula will give you the value of call option. It is just that we'll have to remember all this formula by heart. There is a way, ln into s minus x, which says that what is the confusion that arises here, what is on the top, x or s. Whatever comes first in the alphabetical order, that is s, will be on the top, divided by x. So into r, then comes r plus 0.5 into standard deviation, that is sigma square, into time period. Sigma and time period will come together. Everywhere it will be coming together. So whenever you are doing sigma square or sigma, it will be together only. So this is sigma 12 square and 0.25. Here 0.12 into root of 0.25. So this is how the formula works. Very simple formula. If you get the formula, you will be easily calculating whatever the requirement of the question is. So this is how Black-Scholes model actually works. It is a pretty simple calculation with, if you remember the formulas correctly, which is very easy, very simple formula. It might seem a little odd when you are seeing it the first time, but if you work out 2-3 problems like this, you'll be able to crack it in 2-3 problems time. Hi guys, if you like my video, like, share and subscribe. If you have any suggestion, please comment. Thank you.